In this video, we will look at how to generate a command file for a three-dimensional analysis using efficient software. In this 3D analysis, a 3D plate has a dimension of 100 millimeters wide by 5 millimeters thick and has a length of 150 millimeters. It is fixed at one end and load of 2000 Newton is applied on the other end. The mesh for this FEA analysis is in MED format. In this mesh, the fixed mesh group is given a name of fix, and the mesh group on which load is applied has a name of load. We'll start efficient, and on the first tab, we'll keep everything default. We'll use start for continuation or a new analysis. For the type of mesh, we'll keep on MED, and for the type of calculation, we'll leave linear static. On the analysis tab, mechanical 3D is default, so we'll just leave it like that. For the material, we'll add definition for carbon steel. For the name of material, we'll add CS, and for ease assigned to, we'll write all. Click on add, and the material data will be added to the command file. We don't need to define anything for element type for a 3D analysis, so we'll skip this. For the boundary condition, for type of boundary condition, leave DOF DDL on mesh group as we want to define it on a mesh group. For boundary condition name, we'll write fixed. This is the name that is used to refer to the entire boundary condition. For ease assigned to, we'll write FIX. This has to be exactly same as the name used in mesh file. As we want the entire face to be fixed, we'll write 0 for dx, dy, and dz. Keeping in mind that for a three-dimensional analysis, the node has only 3 direction of translatory motion. We'll click on add, and the boundary condition will be added to the command file. For load name, we'll write force Z. Again, this is just the name which is used as a reference to say that this will be used, or this reference will be used in the command file. For the load type, it will be force on face. Is assigned to, we have load, as this was defined in the mesh file. For if we want to define the force in Z direction. Now here, as we did for the shell analysis, we have to define the force per or force divided by the area. Now the cross-sectional area of the plate was 10 millimeters wide and 5 millimeters thick. So the area in that case is 500 millimeters squared. As the force is 2000 Newton, we need to enter 4 in FZ, as 2000 divided by 500 is equal to 4. We'll click on add to add this force on the or in the command file. Next we go to output, and I'll just click on add all because I want all of the calculations to be entered in the resultant mesh file. Click on save com file and select the location where you'd like to save it. I'll call it 3D analysis.com. Click on save and the file will be saved. Let's quickly have a look at how does this file look like. I'll open 3D analysis. Here you can see that the phenomenon is mechanic and the modelization is 3D. Carbon steel material properties are here. The fixed node group is having dx equals to 0, dy equals to 0, and dz equals to 0. And the force in z direction is applied on the force face of load. I encourage you to use this command file in FE analysis of your own and have a look at it for yourself.